Hello everyone. In previous video we explained some basics in chemistry and we explained the orbits for electron configuration. Now we're going to continue on how to do electron configuration and how to read the information that are required from electron configuration for later uses. Now in electron configuration we said that there are quantum numbers or levels, and we'll call them shell, and then within shells we have subshells. We call them s orbital, p orbital, d or f. Then according to energy, those levels will be filled with electron. So it means that we're not gonna just fill the levels. For example, we have shell, which is quantum number n1, means shell, first shell, it only has s, so one s, and s we said that will have 2 electrons inside it. Then we're gonna go to 2s2, 2p2. Well, let's just do this one in somewhere that we have the s, much easier. Now this is a bit better. Now the levels that we have it, or which one comes first, it depends on energy. So for example, level 1 shell, first shell comes, which has s, second shell, which has s and p. For the third shell it has spd, but 4s has a lower energy than 3d. Now the electrons are willing to go into S rather than go into D. Now why is so? Because each atom, for example, of each element, they want to be in a stable condition and to have in a less energy condition. When those things are going up, their energy is increasing. So if there is an opportunity to feel a lower energy, they will feel that one, then they go for the other one. So for example, 4s will come before 3d, so 4s is lower than 3d. Then will be 4p. Before 4d, there is a lower energy level, which is 5s, and then so on. Each according to energy level, the electrons go inside them. If they fill, they go for the other one. Now there is different way to remember this. Now the funny way that I've seen from student, once when it's exam, I heard the student, he just says something like this, and I just asked him, what is this sound you're making? He said, sorry sir, but I memorized the levels in this order. And then I realized that he's reading s, and then ps, and then ps, and then this, and then ps. This is basically, he was trying to remember which one comes first. Well, I started laughing. I said that there is another way to do it, but anyways, in the exam that he was doing it. Now, we have a way that to know which one comes before the other one. Now, here's an arrangement that you've seen it most probably in chemistry, but we're gonna just revise it. I'm not gonna talk about the shape of those orbitals, the way that the loops they have it. There are videos you can watch those. What does those orbital looks like? Now mainly we're focusing on how to just simply follow the diagonals. Now it's easy to construct this table. Why? Before explaining, so you say 1s, which is 2, basically 3, just levels. Yes, 4, 5 till 7 you go. 5, 6, 7. 2, I'm gonna increase them. S, P, and then SPD, SPD, then ASP, D, F, then here S, P, D, F, S. For the rest of them, no need to go, just write this will be enough. At F, stop it, no need to go further, because the elements that we have them, they do not fall into G orbital or H orbital, so there's nothing goes inside here. I mean, up to here, if you write it, that will be enough. Even those three not required. Now what you do, then you go for the diagonals. Basically, we said that this is the first diagonal, so we're gonna read according to diagonal. Then we have second diagonal, and then third diagonal, and then fourth, and then fifth, and so on. Now those diagonal, basically, we're gonna follow those diagonal to read, which one comes first. This is how they come. So you start with the first diagonal, then you read the second diagonal, then the third diagonal, then so on. So what does it mean? It means that if I wanna know the sequence of this electron configuration, first diagonal only has one s, second diagonal has two s, so I'm writing one s then two s. In the third diagonal I have 2p, I have 3s. Then we go for fourth diagonal, I have 3p, 4s, look, before 3d, and we already know that 4s has lower energy than 3d. Then goes for 3d, 4p, 5s, 5s has lower energy than this one or the other one. Then go for the sixth diagonal, 4d, 5p, 6s, then 7 and 8. In this manner, you'll be able to find a sequence for the electron configuration. So I don't need to memorize anything, just simply do this one. And here you can do it like this. This is the, you can do it in this manner. This is the first, this is the second, this is the third, and this is gonna be the fourth, and this is supposed to be with something much better than the way I did, so at least to be a table shape to know which one is falling under each other. Let's make them nice under each other. If those be under each other, it will be much better. You can make them nice, you'll be able to get the diagonals easily and find the sequence that we have it here. So this is the first thing that we're going to use it to do the electron configuration. Now what do we get from those electron configuration? We will get 4 to 5 information just by doing the electron configuration. What will be the information that we're getting it from electron configuration? So we're going to just write them down, then we're going to discuss them one by one. Now the first thing that we're going to get is valence electron. Valence electron. We're going to get period number. We're going to get group number. We're going to get group name. Then we're going to get element, preferable bonding type. Relative bonding type. So basically by doing electron configuration we can gather those information just by looking at the electron configuration. We can know valence electron. What does valence electron? We will explain, or maybe you already know it. Period number, group name, and elements, preferable bonding type. So just by doing the electron configuration, I will be able to know that which kind of bonding this element is going to have or prefer to have, and then based on that bonding we will see some properties. For example, if it's ionic, you already know the bonding types, we're going to explain them: ionic, covalent, metallic. According to those, we're going to have some ideas about the property of that material, and we're going to relate them when we come to chapter 6. When the mechanical properties we have them, we're going to relate those things together. So we can explain them, why the bonding is important for us as an engineer. Yeah, you know them in chemistry, you already studied them. I'm not going to go into detail of them. I just want you to know them and basically just extract this information from a simple electron configuration process. Now we will start with valence electron. Now for valence electron we have it will be divided into two categories. So before explaining these categories, I'm going to go over those three things. Then valence electron will be easy for us. Why? Because we have it for s orbitals, for d orbitals, for p orbitals. D and f quite a bit confusing. Those two a bit together, we can put them together. S and p are very easy to find the valence electron, but d and f, they have some behaviors that sometimes is not gonna the way that we're finding valence electrons. So we're gonna talk about those about at least the groups there. So let's see, how do we get period number or group name? Now we're gonna look at periodic table. Now periodic table, it's basically invented by a guy named Mendeleev in 1864, if I'm not wrong. He was the one that just basically theoretically found the location of all of this, or all of the elements basically, each of them and their electron configuration. Now how it has been set up, you already know them. Let's just review them. We have row, or its period, we call them 1, 2, 3, 4, 5, 6, 7, and this for us basically is the shell level that we have them. So level 1, level 2, level 3, level 4, level 5, 6, and 7. So basically those two are within 6 and 7 somewhere here, so but that's why they call them 7 and 6 as well. It's a part of somewhere within these two rows. So what does it mean? It means that in this period, for example, they only have, for example, level 1. Let's do, for example, helium, it's 1s2. The hydrogen is 1s1. When it became helium, will be 1s2. Look, the level is 1. When it come here, all of those at the ends, they finish with 2 something. Here they will finish with 3. Here they will have 4. Here they will have 5. Here will have 6. Here will be 7. So this is how we know basically when we do the electron configuration, the highest level number within the electron configuration will tell us that the location of the element. Let's, for example, take this one and we're going to do the electron configuration. For example, this is 33 electrons we have it. We shall have 4 within the electron configuration. We don't have 5. Why? Because it finishes at level 4. So we cannot see 5 within the electron configuration for this element. This is how we will get that. So when we do the electron configuration, we will look for the highest level of the shell or energy level. Then we know that this element is in which period or in which row. Then beside period we have groups. So how the groups basically made? The groups basically made according to the orbits. Those two are finishes with s orbit. This is S1, this is S2. Any of them that you look at them finishing with S. For example, taking this element with 20 electrons, it's a level 4, so it's supposed to finish with 4s2. All of those will finish with S1. So it will 6s1, 5s1, 4s1, 3s1, 2s1, look, 1s1. All of them, they have the same property finishing with s1. This is s2. Now coming over here, those are p orbitals, and p orbit basically contains 6 electrons. So 1, 2, 3, 4, 5, 6 electrons. So you know that this is whoever finishes, for example, in this group, they have, for example, if I'm checking this one, whatever taking it, for example, 81 here, we're taking it from here 6, this is 6, and this is here, because it's p level, will be p, so 6p1, this is p1, and this is p2, p3, 4, 5, 6. That's how it's go. For example, 1, 2, 3, 4, 5, 6, because we have 6 electrons in p. So anyway, excuse me, anyway within this column, they have a property that they finish with p1. Here p2, p3, p4, p5, and p6. And that's going to give us another information which we call it valence electron. Why? Because all of them, they have similar behavior due to having similar valence electron. So those are basically the p orbits. We have it there. Now the middle part here, this one here, those are d orbits, and d contains 10 electrons. So you'll see that from 3 to 12 it will be 10. Those are basically d1, d2, d3, d4, and so on till D10. So 10 groups for D, because we know that there are 10 electrons inside them. By the way, those are, you already know them before, we just review them to know that what we're dealing with. So anything that finishes within here, they will have D inside it. So for example 5, they will having something related to D at the last part of the. We will talk about this one, it's a bit difference, their electron configuration. We'll talk about them in a bit. And those are with F, basically they will be 14. If you count them, they'll be 14 electrons, because F orbital will have 14. Those are F orbitals, which basically have 14 groups, 14 electrons inside. So if I know the electron configuration, I'll be able to know the period number. I'll be able to know the period number. I'll be able to know the group number as well. This is group 1, 2, or the rest of the groups. I'll be able to know it easily. Then, according to the group numbers, if we know the group number, then we know which kind of group name we call them. I mean, the type of elements that we have them. For example, group 1, they called alkali. I mean, this is basically not hydrogen. The other one, they call them alkali metals. The second group, they call them alkaline earth metal. I mean, for example, here those green one, halogens. The white one, noble gases. I mean, the one in here, which is starting from D2 till D10, transition metals. So by at least we'll be able to guess, I mean, to know the name of the group name based on the group number that we have. For example, we call this one S1. We know S1 will be alkali metals. S2 will be alkaline earth metal. And those are the name of them that we can have them. There are some others, different things. For example, those olive color, basically, some kind of olive, green olive. I mean, rare earth elements and lanthanides elements, we have it here. There are some metallic, non-metallics also. Basically, those groups here, they have some metallics and metallic with the groups as well. So this is, you know how the periodic table. So in a face-to-face classes, we were just giving them a number of electron, and we're asking them to do the electron configuration, and we're asking them to find all of the information without having the periodic table with them. Just by looking at the electron configuration, you'll be able to find all of this information. Now we're going to show to you how we do this electron configuration and how do you find those information from the electron configuration. Well, before going, we have a valence electron. Now what does valence electron means? Valence electron are those electrons at the outermost shell of the element. The outermost shell of the element. Now if you remember, let's come to the, well, let's show another picture. Okay, we're gonna talk about this one, but let's talk about the valence electron. Now if you imagine this is Na, and this is the way that we have the electron configuration, whatever, if you think of it. Now the outermost shell is this one. The outermost shell is the last shell that we have it, and the number of electron inside that shell we call the valence electron. This is a valence electron. For example, Na has one valence electron. If you're checking chloride, we have the outermost shell. The outermost shell is this shell. So we have 1, 2, 3, 4, 5, 6, 7 valence electron at the outermost shell. 7 electron at the outermost shell. Now what does this valence electron is teaching us? For example, if there is one electron and we know that it's going to be filled with, for example, 8 electron, does this element is going to borrow 7 electron, or is going to just give up on this electron to give it to someone? For example, this is 7. This 7, you're not going to give it to anyone. It's preferred to take 1. So that's what basically will come to the chemical reaction that we have them, the electronegativity, electropositivity of the elements, atoms, based on the way that they have valence electron. And I want to be stable, we're giving this element, and this guy want to stable, will take it. So this is, we're going to talk about this one later as well. So valence electron is basically the number of atom at the outermost shell of elements that we have it here. Now this is a bit tricky for the D. We're gonna explain some example. Let's explain them on this. We're gonna do an example here. So let's take some let's do some example. Let's take first, well, let's take chloride. Oh, we already know chloride, but let's take aluminum 13. So let's take aluminum 13 here. So we're going to take 13 aluminum, and we're going to do the electron configuration based on this one here to see how does it work. So we have Z equal to 13. When we're going to do the electron configuration. So we will start here 1s, then we have 2s in the second diagonal. So this is 1s, this is 2s, then 2p, 3s. So we're writing it 2p, 3s. I don't know how many I needed, but I'm writing it down. If I don't need it, I will delete them. Then we'll go for 3p, 4s, 3p, 4s. Let's say maybe enough because we have 13, not too much. Let's see how does it go. 2 electrons here, 2 electrons here, 6 to p, became 10, 2 to this one, this became, so 1 comes here, then we don't need the last part here, we don't need 4s. Now I know the electron configuration for this element, whatever it is. For example, we know it's aluminum, it's 1s2, 2s2, 2p6, 3s2, 3p1, and the total number of electrons is equal to 13. Those are 10 and 3 became 13. So what do I get from this electron configuration? Well, the highest level that we have is, highest, the shell that we have it, we have 3, isn't it, the shell number, the outermost shell, which is N, they call it, we have 3. So we know that this element is in the third row. Why? Because the highest level I have it here, it's 3. So we know it's in third row. This is 1. Second, it's in the P groups, So imagining in this way, imagining in the periodic table, there is 2 groups for S, there are 10 groups for D, and then 6 group for P. So if you, for example, measure group 1, group 2, then 3 till 12 there, then 13 till 18 will be here. So what does this mean? It means that if I want to find the group number, if it is S, it's easy. If it's finished with S1 is group 1, if it's finished with S2 is group 2. So I'm gonna write them down somewhere here, at least. So if it is S1, it's finished with S1, this is group 1. It's easy. S2 will be group 2. Then we have D1 will be group 3, and D2 is gonna be group 4, and so on till, for example, it's gonna be, I'm not gonna write all of them, say go like this, and D10 is going to be 12. Then after D10 we have P, so P1 will be group 13. There is an easy way to remember this one. Then P2 and P will be 14 until I'm not gonna write all of them again. So we know that when it reaches to P6 is going to be group 18. Now how we can find these things easier? Group 18 just disappeared there. And we know that P6 is going to be group 18. How can I simplify the groups? Simplifying the group number for S, they're easy because 1 and 2. When it comes to D, always the number of electron inside D, for example, how many is plus 2 plus 2, this is going to give you the number of group. So how many electrons do you have inside D? Plus 2 is going to give you the group number. Why? Because we know that there is 2 group before D coming, which is, that's why we can, for D, inside D we have 2 electron. 2 plus 2 will be group 4. I have 9 electron inside D. 9 plus 2 is going to be 11, group 11. Why? Because D started with 3, so always there's 2 difference between them. Look at them, 2 to 4, 10 to 12. I mean, there is 2 difference. So if you know the electrons inside D, plus 2, this is going to be group number. This is the group number, by the way. This is the group number. This is the group number. Well, when it comes to P, there is basically 12 group before it, so the difference between them is 12. Why? Because 10 for D, 2 for S, 12 group before group P, I mean the orbital P group start. So we always say that this number plus 12, so 1 plus 12, always 12. Why? Because we have 12 group before group P start. We always, this is constant 12. So we know that this group is 13, will be the group number. So we know the group number easily by looking at the last part here. This is how we find group number. This is how we find group number as well. So we said that for this 3 is going to give us what? This 3 is going to give us period. This is period number. And this is P. We know that before P there is 12 group, so there is 1 electron. 1 plus 12 is going to be 13, and that's going to be group number. That's going to be group number. Now for the group name, well, basically we were asking those groups that at least they are clear for student what will happen. I mean, some of them they have multi group, I mean they have multi name. For example, in P1 we have metallic and non-metallic inside it. So it can be, you can just simply write metallic, non-metallic. For P1, P2, P3, P4, I mean those are metallic, non-metallic elements, we have them inside them. P5, it's halogens. P6, it's going to be noble gases. So basically by knowing even the number of electron inside P, we know which of the group number will be there. For D, basically except D1, D2 till D10, we explained on that periodic number, those are transition metals. D1 is going to be the rare earth metal, they call them. I mean S1, S2, S1 is alkali metals, S2 alkaline earth metals. So we know simply by just knowing the number of electron and the orbit, we know the group name as well. We know the group name. So you realize that the last one, the last part here, I mean the last part will be used to find the group number. The highest level will be used to find the period number, and here's come the valence electron. Now valence electron basically here is the number of atom at the outermost shell, and the outermost shell we have it is 3, so we're gonna use all of 3. For example, this is 3, this is 3, this is 3. So for valence electron I'm gonna take 2 of them. For valence electron I'm gonna 2 of them. Why? Because the outermost shell we have is 3s2. When I say shell, it's not orbit. Remember, shell is the level. Outermost shell, it's the level. I'm not saying sp. I'm not saying the last one. No, we say the outermost shell is basically level 3. So we have 3s2, 3p1, 3p1. So it's basically 3 will be the valence electron we have it here. 3 will be the valence electron. Why? Because 2 electron here, 1 electron here, so the valence electron will be 3. Now if I know the valence electron and I know the bonding type, I'll be able to know that which type of bonding this element may prefer. Is it willing to lose those three electrons and to be electropositive, or is willing to share it with others? So we're going to know this one when we deal with the bonding. Let's have another example in the somewhere else within the S group. I will say with the S group, within the S group. Now within the S group, basically anywhere that you're taking it, let's take something a bit, for example, let's take this, okay, 56. We're going to take 56 BA, 56 here to see. We're expecting it to be what? To be 6s2. We're expecting to finish with 6s2. 6s2. So we'll go and do this electron configuration for an element with 56 electron. So we have Z to be 56. Then we're going to continue typing with 1s, 1s, we have 2s, 2p, 3s, 3p, 4s. I mean, you can read from the groups, yes, 4s. Then we come here 3d, 4p, 5s. We're writing those three first. So 3d, 3d. Then we're going to go for 4p. We're writing 4p, 4p. Then we're writing 5s, 5s. Then we're going to continue for 4d, 4d. We're going to go to 5p, 5p. Then we're going to go to for 6s. We were expecting it to finish at 6s, yes, but let me writing it for f as well, for f as well. See, now we're starting with the number of electron 2 here, 2 here, this is 2, with the 6 became 10, then 2, 2, oh, sorry, this is 6, this is 2, became 20, 10 for here became 30. So far we consumed 30 electrons, then 6 here, 2 here, that became, and then 10 here, and 40, that's 48, 48 we have, this is 52, 54, and then 2 will be inside here. So we don't need, sorry, we don't need this part for f here. As we're expecting it to finish as 6s2, then it end up as 6s2. Now let's find the information. The highest level we have it is what? Is 6. The highest level is 6. The highest level is 6 here, 6 here. So this is going to give us what? Row number 6. So group, I mean period number will be 6. Why? Because the highest level is 6 we have it. I don't have 7 years. That's the first thing. Then it's finished with S2. S2 basically is group 2. I mean, look, this time I'm taking this one I'm gonna say this is S2 is gonna give me what? S2 is gonna give me, this is gonna give me the group number, it's basically 2, group number 2, because it's S2. Then with group number 2 we know that the name of the group, basically this one is going to give us the name of the group. Group number 2, it has a name which is alkaline earth metals. Those are 3 information. Then the last one will be what? The valence electron we have it. Now the valence electron we said what? We're gonna check the outermost shell. Which one is the outermost shell? I mean, we don't have bigger than 6, yes? So 6, the outermost shell. 6 is the outermost shell that we have it here. I mean, we only have one 6, which is 6s2. So the outermost shell is 6. We're writing it somewhere. So the outermost shell is 6, and within how many we have it with 6, we only have 6s2. So if you find out the outermost shell number and then write all of them, for example, we have 6s2, if I have 6p, we're writing it, all of them we're writing it, then you're going to take the electron within, the summation of electron there. So we have only 6s, and that's going to be electron configuration, the valence electron basically comes from the summation of those things. So I'm gonna, since it's the only one, so we only have this part, and this is gonna give us the valence electron. So I can write it here, valence electron will be 2. So valence electron will be 2. So I have 2 electrons at the outermost shell of this electron configuration. Now with these two, they most probably know that these two elements, they want to just simply give it away. So this is, we will come to the electron, the bonding type, and we understand this as well there. Now you realize that N, S, and P, they have no problem in finding electron, valence electron, group number, group period number, and with the group name as well. This is the group name we have it. However, we're going to do one which is with D group. We're going to do with D group as well. Well, let's have it another video, not to be long. So we're going to make another video for the D group to see what do we have inside D groups. We have some special cases there, and we have to treat them differently than the other one, especially for the valence electron. Thanks for listening.